Welcome my Algebra 1 friends. This is our first instructional video for the year. And if you are watching this video, then you should have completed Investigation 1 in Unit 1 in our Concept 1.1. So there's 3 sections to Unit 1, and we are in the first section, and you should have completed the investigation task before you are watching this video. So our essential question in Investigation 1 is, what can the structure of an algebraic expression, change my pen, reveal, I'm going to think about what those words mean, about the mathematical or real-world situation it models. So an algebraic expression is some kind of mathematical sentence. We think about it as how we communicate with math, and it's going to contain numbers. It could be a variable, it could be a coefficient, a constant, and it's going to contain those things, and then operational symbols. So like plus, minus, the squared, the square root, the equals, or no equal sign, sorry, expressions don't have equal signs. And so, and we'll also work with equations. We'll talk about that in a minute. So our big question is, how can the way we put together these numbers and symbols reveal or tell us things about the situation we're modeling? And let that lead us to this idea of mathematical models. So mathematical models are what we're going to be working with pretty much all year in Algebra 1. You've been working with them your entire math life. You just don't realize it. We model things in all different kinds of ways. But in math, when we use a mathematical model, we use logical symbols to make sense of things that are happening in the world, to make sense of the world around us. So today you'll need your notes. That's your ISN, and you'll need the handout parts of an algebraic expression. You're going to use that in your notes. So we're going to start out with a quick vocab review for the parts of an expression, so that when we use these words, you understand what they mean. If it's not review, it's fine. You're going to pick it up. You notice how I've just made that bigger so I can write on it better for you to see better. You're going to have trimmed this page down and glue it in your notes on the next open page. And if you need to pause the video and do that, go ahead and then come back and join me. So we're going to look first at the 3 and the 5. And those terms, those numbers are called coefficients. Coefficients. Barely fits. I'm not writing very well right now. So coefficients, and those are numbers that are going to attach themselves to a variable. So here is a variable, x and y. Those are variables. So coefficients attach themselves to variables. Variables are letters that represent something that can change, a quantity, a number that can change, a value. So 3 is not changeable. It's a coefficient, and it's just 3. 3 is always 3. 3 is never 5. It's never 1. It's never 2/3. But x could be anything, and it depends on how we're using it and what it's going to represent in our expression or equation. So that's the difference between that coefficient and the variable. We also have this nice little number 9 over here, and that is a constant. We call it a constant because it does not vary. It stays the same. 9 will be 9, will be 9, will be 9, always in this expression. As opposed to the term 3x, the term 5y, the term 9, 3x can change depending on what x equals. 5y will change depending on what y equals. But 9 will be constant. And those terms, 3x, 5y, and 9, are going to be any numerical value represented or like separated by a plus sign, a minus sign, an equal sign, a less than or equal sign, different, anything that separates them that's not multiplication or division is going to tell us what our terms are. So hopefully that's a little bit of review for you. If it's not, then now you have those terms in front of you, and if you're not sure, if you run across them as you're working on a problem, or you hear them in a video, or a friend uses them when you're talking about the math, then you'll be able to look back at your notes until you get familiar with those terms. So what we are focusing on in 1.1 is this difference between an expression and an equation. So an expression will contain symbols and numbers, and then an equation is going to have two expressions with an equal sign between them. So you notice equation equals, that's your clue. Same kind of root to the word, and that's what makes an equation different from an expression. So you're looking for the equal sign. The equation will represent relationships, and we think of it in math writing as a complete sentence where is the verb, the equal sign is the verb, and we think of the expression as a subject in the number sentence. So let's work a couple examples to make sure we understand the difference between an expression and an equation and how they are used. So here's our first example. Grace works 7 hours this week and earns $12 per hour. So the expression we would write is 7 times 12. 7 is the number of hours worked, and 12 is money paid for each of the hours. Now, if I wanted to represent this situation with an equation, I'd say 7 times 12 equals 84. And that 84 would be how much Grace earned this week. So the difference is that the algebraic expressions and equations can be used to generalize or to represent this situation. But we want to see how to generalize that. So we're going to look at another example. So this is very specific to this particular week where Grace worked 7 hours. So what if we don't know what week it is and how many hours she worked? That's going to be generalizing our information, our example. So let H equal the number of hours Grace works in a week. And let E, so here's H, E is going to equal Grace's earnings in a week. So we're going to write down the expression that represents this. And that expression is going to be 12 times H, because 12 is the dollars per hour that she's going to get paid. And then H is going to be number of hours. So this gives us the same information, but in a more general way when we don't know how many hours in a given week she's worked. We can apply that to any week. We can say, 3 weeks ago, how much did Grace make? And then we ask the question, well, how many hours did she work? Boom, 12 times that number. Now we know how much she made. Now if we want to put that into an equation, we've got 12H equals E. So E is how much she makes in 1 week. So this algebraic equation generalizes that relationship between the number of hours Grace works and her earnings, and it's a pretty useful tool that we can apply to any week we want to talk about. So that's where we're going to stop today. You'll have a second video for some notes to help us as we turn words into algebraic expressions. And then you'll be ready to move on to investigation 2.